So here we're going to go over the problem, and I will go straight forward and solve it based on the understanding we have so far. Okay, so the potential difference in the current in the circuit, right, represented by this. So we know V, there's potential difference. We know there's A here, right, and there's current, right. Okay, and now I want us to find the power, which we know will be let's see, we have a unit of watt, right, volt amperes, but something is here, reactive volt amperes, meaning that you have a unit of VAR if it's more than 1 RS, right. Okay, well, write it in small. Right, and we know per the notation that we have, if we have power, meaning that it will be positive side, it will be just positive, right. And then if we have let's see, any reactive power, right, any reactive power, it becomes plus or minus, right. So let's go for this. So meaning that before we do this, we have to find the apparent power before we can find this, right. So let's see, we know apparent power is equal to a VI, right. But if we are doing any computation that already has the values of the V and I in a complex notation, right, in this what's the name, in this polar form, is S is equal to V, right, I what, asterisk y. The asterisk, which you say is the mean that we conjugate the current, right. Okay, just to mean that we have let's see, V, where V is 100 200, right. So let's do this. Okay, 100 200, right. Okay, so that's 100 plus 200. Let's bring it down. Okay. All right, this J, V, right, and then I, well, we have I to be 10 5, right. So that's 10, and then we have 5. Here's a G, and because this is asterisk, so to make it work easier, you can even write everything as it is, right. You know I already, just write everything so that you always remember. So here becomes a what, but the I is a plus, right. So you just put a plus, but then don't forget the asterisk. Don't forget the asterisk. Or you can choose to change everything straightforward if it works for you, right. So that means that we have 100 plus G, okay, 200, and we have 10 here. If we do conjugate, we end up getting more minus, right, 5. So our G and our G, yes, minus, right. Okay. And now when it gets here, you don't have to always do the manual computation, right. You've seen how to go using the calculator, right, to help you get the values directly. So that's what we're going to do now. See, the other thing you have to do is you have to be able to change your calculator to complex mode, right. Change to complex mode. So we are going to do that now, and you just punch everything in as we see. Okay, so let's see. So now how do we change the complex mode? If we're to be the normal calculator, just go to mode, right. You see your options and you choose complex, right. This is a bit different interface, but still the same. And now that I have that, I'm multiplying through brackets. For me, I'll just how I'll do it to make my work easier. And I just go on and see 100 plus 200. When it comes to the calculator, it wants you to put this notation. It uses I, right. This J here, it uses I, and then you get that by seeing where you have the engineer. You press the top, you get the I or the J. Yeah, that's the equivalent for the G, right. I, and I want you to put it before, not after the number. Okay, I want you to put it after the number, not before, right. So we have I here, right? And then we have 10 minus 5 I, right. So let's see if we put in the I before it to work. We have an I here. So if I can make our calculations easy. It may or may not work depending on the calculator you are using. Let's see. Oh, it works. So you can just punch everything straight forward. Right. Here's 10. Sorry, here's 10. Yes, then. All right. So yeah, that's what we have, meaning that the value that is given us will be 2000, right? And then we have a plus, and then add d, right? Multiplying the 1500, so 1500, right? And what are we finding? This is s, right? So the unit, very important. So we end up getting the unit of what? Apparent power is VAR. It's just VA, volt amperes, right? So VA, unit rem. So we have a unit as well. So that's it. But the question itself wants us to find the power and the, what's the name, the reactive power. And how do we go about that? Because we have it in this notation, it's very clear that we end up getting P to be per the introduction that we had, right, on AC power notation. So this would be this, watts, right? And then we have the reactive power. So you said reactive volt with amperes, right? So that's reactive power. That's 1500, and that's volt amperes reactive. So let's make this okay. The unit very important. If you miss a unit, it could mean you're talking about something different, right? So volt amperes reactive. All right. And at times you can see this as just small VAR, the same, right? But the watt is always capital. All right. So that's